Hello and welcome to the second part of the course on temperature measurement using sensors. In this session, we will understand about types of sensors and transducers. Transducers or sensors can be classified according to their application, method of energy conversion, nature of output signal, and so on. I will be talking about each of the transducer mentioned here. On the basis of transduction, we have the following classification: capacitive transduction, electromagnetic transduction, inductive transduction, piezo-electric induction, photovoltaic transduction, and photoconductive transduction. So first of all, let's talk about capacitive transduction. We all know that a typical capacitor is comprised of two parallel plates of conducting material separated by an electrical insulating material called a dielectric. The purpose of the dielectric is to help the two parallel plates maintain their stored electrical charges. The relationship between the capacitance and the size of capacitor plate, amount of plate separation, and the dielectric is given by C is equal to epsilon A by D, where D is the separation distance of plates in meters, epsilon is relative permittivity, which depends on the material which is used as dielectric medium. A is the effective, or we can say the overlapping area of capacitor plates. This is measured in meters square. So C becomes the capacitance, and the unit of C capacitance is farad. Let us consider an example of measuring distance traveled by an object. This change in distance from home position to some other position can be converted into change in the capacitance by varying any of the three parameters. The first method is keep one of the plate of capacitor fixed and move the other plate away from fixed plate. This way, the distance between the two plates of the capacitor is varied, keeping the other two parameters, that is effective area and dielectric, as constant. Second method is again keep one of the plate of capacitor fixed and move other plate over the fixed plate. This way, the effective area between the two plates of the capacitor is varied, keeping the other two parameters, that is distance and dielectric, as constant. Third method is to keep both plates of capacitor fixed and move the dielectric. This way, the permeability of the capacitor is varied, keeping the other two parameters, that is distance and effective area, as constant. Therefore, in capacitive transduction, the measured entity is converted to the change in capacitance. The next is electromagnetic transduction. According to Faraday's law, whenever a conductor is placed in a varying magnetic field, EMF is induced, and if the conductor circuit is closed, current is also induced. The instantaneous EMF induced in the conductor is directly proportional to the time rate of change of the magnetic flux through the conductor. Using this principle in electromagnetic transduction, the measured entity is converted to EMF induced in conductor by change in the magnetic flux. Therefore, electromagnetic transducer is a self-generating active transducer. The next is inductive transducer. In inductive transduction, the measure end is converted into a change in the self-inductance of a single coil. It is achieved by displacing the core of the coil that is attached to the mechanical sensing element. In piezoelectric induction, the measurement is converted into a change in electrostatic charge or voltage generated by crystals when it is pressed mechanically. In photovoltaic transduction, the measurement is converted to voltage generated when the junction between the dissimilar materials is illuminated. In photoconductive transduction, the measurement is converted to change in resistance of semiconductor material by the change in light incident on the material. The next classification is of primary and secondary transducer. Some transducers contain the mechanical as well as electrical device. The mechanical device converts the physical quantity to be measured into a mechanical signal. Such mechanical device is called as the primary transducer because they deal with the physical quantity to be measured. The electrical device then converts this mechanical signal into a corresponding electrical signal. Such electrical device is known as secondary transducer. The next classification is of active and passive transducers. Active transducers do not need any external source of power for their operation. Therefore, they are also called as self-generating type transducers. In other words, active transducers operate under the given energy conversion principle. For example, on pressing the piezoelectric material, the output is electric potential. Similarly, on applying mechanical pressure to strain gauge, the output is change in the electrical resistance, which can be converted to electrical potential using Wheatstone bridge. Passive transducers need external source of power for their operation. So, these are not self-generating type transducers. A DC power supply or an audio frequency generator is used as an external power source. These transducers produce the output signal in the form of variation in resistance, capacitance, inductance, or some other electrical parameter in response to the quantity to be measured. Next classification is of analog and digital transducers. In analog transducers, the analog signals are continuous functions of time. Therefore, the input quantity to an analog transducer is an analog signal. For example, sensors for measuring temperature are thermistor, thermocouple, etc. Then to measure travel, we can use linear variable differential transformer LVDT. To measure angle, we can use rotary variable differential transducers RVDT. To measure force, we can use strain gauge. To measure flow rate in a pipe, we can use flow meter. Digital transducers. Here, the digital signals occur in the form of pulses. Therefore, the input quantity to a digital transducer is a pulse train. For example, shaft encoders, digital tachometers, Hall effect sensors, limit switches, etc. Another classification is of transducer and inverse transducer. The input to the sensing elements can be in the form of resistance, capacitance, and inductance. After passing through transduction element, it can be converted to voltage, current, displacement, sound, pressure, etc. Transducer can convert non-electrical quantity to electrical quantity. This can be seen as piezo-electric effect. In inverse transducer, this converts electrical quantity to a non-electrical quantity. This can be seen as inverse piezoelectric effect. In the next part, I will talk about measurement of an important parameter, which is temperature. Till then, if you have any doubts, you can mail me at the given mail ID. Thank you and happy learning.